Welcome to the Unit 3 Circular Motion and Gravitation video lecture. This is going to be covering centripetal force with the normal force. To motivate today's lesson, I would like to show you a video clip. So this is the machine that we're going to be working with. It's called Gravitron. It spins super fast. As a result, some forces occur such that the students will get stuck to the wall. They won't fall down or go up, but they're stationary and they're pinned against the wall as it speeds up. As you see, as it starts to slow down, here as it starts slowing down, you're going to see people start falling. Okay, so that is what a graviton is. So the graviton is a common amusement park ride where the room spins so fast that the occupants feel pressure against the wall. When a significant speed is reached, the floor drops, but the occupants do not slide down the wall. Let mu equals to 0.7 and the ride radius is 2.5 meters. The first thing that we're going to do is draw a free body diagram on the person in the ride. There's a force pointing up. I'm not going to tell you what it is, but we know that force of gravity is going to be equal and balanced to it, and that's going to be force gravity. The force pulling them in towards the center of the circle is going to be the force normal. From the bird's eye point of view, looking down, you're going to see it as force normal. So if we now take a look to see what the force is here that is going up, it's actually the force of friction. Because force normal is pointing inwards, force normal isn't pointing upwards. It's actually force friction. So here in the vertical direction, it is force friction, which is pointing up, and force gravity, which is pointing down. Now, we are going to calculate the centripetal force equation. First of all, we're going to look at it from the side view. From the side view, we see that the centripetal force, summation of Fr, is just equal to the force normal. Then in the vertical direction, we saw that there was no movement. The person did not slide up or down. So we say the summation of the forces in the y direction equals to 0. The question is, what is holding the rider in, keeping him from shooting out of the room? What is keeping him against press inside the room? The answer would be the force normal. What is the force or forces that is or are supplying the centripetal force? In this case, the summation of Fr is just equal to Fn, which is just the normal force. Question: what is keeping him from sliding down the wall? It is the force of friction. What's trying to push him down would be force gravity. The equal and opposite force in the vertical direction that balances force gravity is force of friction. But wait, why is the force friction in this situation upwards? There are two answers. The first one would be the friction force is always seen to be perpendicular to the force normal. That is one explanation. But also notice that that in theory the person is supposed to drop down. The force keeping the person from sliding down the wall is the static force of friction. It must be pointing up to balance the force of gravity pointing the person down. Now, we're asked to write the equation for the centripetal force and describe what direction it is in. The force centripetal, this should be Fr, is equal to the force normal. We could make the substitution. mv squared over r is equal to the force normal. Notice that the centripetal force here is in the horizontal direction. So what happens to the normal force as velocity increases? Velocity is on top with the squared. So the answer, the normal force will increase because they're directly proportional. This is on top of the fraction, goes up, so force norm is also going to go up. The velocity is squared. This means it's a power 2 with the normal force. So if velocity here doubles, the normal force would be quadrupled because of this squared term. If you plug in a 2v here, it becomes 4v. What happens to the force of friction then as the velocity increases? Well, we know that force of friction equals to mu n. And we know that mu n is just, in this case, mv squared over r. So we can say, in this case, for this scenario, the force of friction equals to mu mv squared over r. So the friction force will increase if the v increase. Like from before, it has a direct relationship. But it is also squared because, do you see the power 2 here? It is also squared. So if the velocity here is doubled, the force of friction here is going to be quadrupled because it is 2v squared. 2v squared is going to be 4v squared. Do you see how there's that 4? That's how it quadrupled. So the force of friction will also quadrupled. Whatever happens to the force normal is going to happen to the force of friction as well, because they're super related. Force of friction equals to mu force normal. What is the minimum velocity required to keep this person from not falling due to the gravity? So in this case, we're solving for v. Velocity, v equals to our question mark. So here's the answer. We set up the vertical direction formula because that's how we're going to get the v. Notice that the force of in the y direction equals to 0. You should have seen it before from the beginning. We said it right here, vertical direction, force of y equals to 0. Then we add Fg to both sides. That's how you get force of friction equals to Fg. Now you can make the substitution. Force normal equals to mu n times mg. The question is, you need to know what the normal force is. I think I wrote this as, this should be Fn, yeah. I just write it force of normal. You could make that substitution here that this should be Fn. I just wrote it n for normal force, but I write F of subscript n here to keep it consistent. So the normal force is equal to mass times velocity squared over r. We saw that in the last slide. Now you can make the substitution. This should go. So this should all go in here for force of friction, for force normal. And that's what you should get. Mu mv squared over r equals to mg. The masses should cancel out. Yep. And you should multiply by r and divide by mu. You should get v squared equals to gr over mu. Take the square root, you get, now you can plug it in, you get 5.9 meters per second. This is very important. This is the important thing to understand, because the question is going to ask, does the person mass affect the required velocity to keep the person up against the wall? The answer would actually be no. The velocity only depends on the g for gravity, the r, which is radius, and the coefficient of friction, which is divided by the bottom. This is one of the FRQ questions that I submitted to College Board that might appear on an exam. This is referred to a paragraph response question. So Ian is the director of NASA and is tasked on designing a next generation space station. One big problem in space is that the astronauts' muscles and bodies will break down if there isn't any gravity, and as a result, no way to work out and stay in shape. Using what you know about centripetal acceleration, draw and design a space station and describe in a coherent paragraph how it would work to fix the issue of gravity. This is an example of a working space station that creates gravity. And the way it works is that this is the main area and it behaves like a circle. And there are masses, like right here where people stand, that revolve, that has a tangential velocity, like in this case. The space station has circular motion with a constant velocity. The fact that it can move in a constant velocity around this circular orbit, as a result, there is going to be an FC towards the center. The change in the velocity direction creates a centripetal acceleration, and as a result, a centripetal force arises, which always points towards the center. But we know due to Newton's third law that there is going to be an equal and opposite force, which is going to be force gravity, which is going to go to balance it. So the force of gravity is created as a result due to Newton's third law, an equal and opposite force to the centripetal force, Fc, or I can call it Fr, due to Newton's third law. That is how you produce the artificial gravity from the spinning of the object and having the centripetal force be balanced out due to Newton's third law. All right, so there you go. That is everything that you need to know when it comes to the centripetal force with the normal force in it.